Prove that as x tends to 0, limit x tends to 0, 1 minus cos x by x is equal to 0. So let's take up the expression. So the funda is we have to make use of this particular formula. Which formula? Right? Limit sine theta by theta as theta tend to 0 is equal to 1. We have to make use of this particular formula. So for that, I need to express the numerator in terms of sine. How will we do that? The clue is very clear. I have highlighted that. So what we have to make use of is cos 2x is equal to 1 minus 2 sine square x. Okay. So we'll start off with cos 2 theta is equal to 1 minus 2 sine square theta. So 2 sine square theta, I can re-express this as 1 minus cos 2 theta. Now, within this, if I substitute, okay, I'm going to substitute here, theta or 2 theta is equal to x, because we want, remember, we want this particular expression, is it not? It should be cos of x. So 2 theta, this entire thing has to be equal to x. So what happens to theta over there? Yes, it becomes x by 2. Which is equal to 1 minus cos of x. Okay. Next, let's go back to the question. So what do we have? We have limit 2 times of sine square x by 2, this entire thing divided by x as x tends to 0 is what we have. These are in brackets. But looking at this expression, we need, first thing is we don't need square. Second thing is we need the same expression as x by 2 over here. To do this, we're going to divide both numerator and denominator with 2. Okay. So what do we have over here is, I'll write it here itself, limit, we have 2 times of sine square x by 2, this thing is divided by 2, and the denominator is also divided by 2. So that's how we can handle this. So we end up with 2 and 2 getting cancelled. Okay, but we still have square. What to do with that? We know that square can be expressed as, a square can be expressed as a into a. So sine square of x by 2 can be expressed as sine of x by 2 into sine of x by 2. And of course, this is a single term, so I'm writing with this. So this is your entire new expression. Now we know that algebra of limits, we can apply the limit to each of this function individually. So we end up with this. Into limit x tends to 0 sine x by 2. Now this is nothing but 1, while the other expression is sine of 0, right, by 2, which is 0 itself. So sine 0 is 0 and our overall result is 0, and we have the proof. That's it.